Practically two-thirds of Indian population is directly and indirectly dependent on agriculture. And when you talk about agriculture, as per Government of India and Prime Minister of India dream, making farmers' income double, one of the major things which comes up to doubling this income is the livestock. It is not possible to double this income of agriculture only from hardcore agriculture. So the role of livestock becomes very, very critical for rural livelihood as well as for the protein nutrition to all the Indians. So ultimately, livestock is a critical factor for all of us, whether we are a consumer or we are the farmers. Well, this 60-65% of the rural India contributes from the agriculture around 1/4 of total Indian economy. And from that around 20-22% of national GDP, practically 1/4 is coming from livestock. And that livestock around 12 lakh crore worth is adding value to all of us. And in that, practically 60% of input cost is the feed. Whether it's the poultry, whether it's dairy or aqua, the feed is a very, very critical thing. Thanks to all our farmers, we are growing in poultry with the pace of around 8 to 10%, and in aqua, it's more than double-digit growth for last 20 years. Thanks to Tarun Sridhar sir, with their support and all, aqua has gone to this level. Thanks to your passion, sir. But at the same time, all these things is also putting pressure to the raw material. And today this panel will enlighten us in terms of raw material limitations and the solutions to that. India being such a big nation also was dependent on import of petroleums. The government of India decided to produce few of it from the grains, and ultimately we started with the molasses, then with broken rice, and then with the corn. Ultimately, when we use energy source from these grains, whatever left over, which was previously considered to be a waste, actually becomes a critical nutrient for the livestock, DDGS. And another thing which is becoming is a newer one is how we can utilize the waste from the food and feed, and there the new technologies comes up of making the insect meals.
A lot is being discussed about the availability of DDGS, how it is going to go up. And most of the knowledge we have about the word DDGS, fortunately or unfortunately, will come from USA, where it has been a very standardized, uniform product now for nearly 2 decades. I don't expect that to happen in India. To avoid this whole debate and discussion around food versus fuel, the government policy very clearly says that only the damaged and surplus food grain will be diverted for fuel. Now, there is our problem where it starts. We want to know whether it is coming from surplus grains or damaged grains. If they are damaged grains, let us see what will happen. Now, from roughly around 1 ton of corn, we will get around 300-315 kilos of DDGS. And from 1 ton of rice, maybe around 200 kilos of DDGS. These figures might vary depending on the technology being used, but they are roughly there. And I will request Mr. Padi to change the word aflatoxins and use a much better term, mycotoxins, because we are not dealing only with one single aflatoxin. Yes, it is important. Now we have regulations coming. Now we already have regulation for milk, afla-M1, but that is important for animal and human health both. And just because of this fact, remember, nothing of the the mycotoxins starting from grain are going to ethanol. They are going to get concentrated anywhere from 3 to 5 times in DDGS. And the FCI is not going to sell good quality food grain for ethanol production. It has to be either surplus declared by government or damaged grain. So we have to be careful, and we want to know whether it has come from damaged grains or from surplus grain. But more importantly, which grain? Yes, for last few years, most of the DDGs available in India was coming from rice. But I have been observing the industry. I have been a regular visitor to the ethanol plants, grain-based ethanol plants for last 12, 13 years. And I have actual data from the plants using different grains. They can use corn, rice, sorghum, many other things. The problem is they don't have much control. They don't exert much control on the mix of grain. Whereas to us, while using in feed industry, that matters when they are expressed as percentage of protein. The amino acids, different amino acids as percentage of protein remain around the range. They don't change much for the given grain. If you compare corn DDGS with rice DDGS, then you'll see big differences in different very crucial amino acids. And unless we know what is the source, what is the blending, it will be difficult for us to assume value. Unfortunately, in India, even today, most of the people operate on amino acids basis, but they are all assumed or table values. Actual analysis done is much less. To add to the fact, now whoever is analyzing, so we must know where the DDGS is coming from, at least what is the mix being used. Unless that happens, we will not be able to utilize full value of the material. If we take and do a theoretical calculation, but most of these are actual figures, you can see from different grain combination, the protein can go from 27 to 51. Now, calling all these by one single name, one single ingredient itself, I don't think it makes sense. The first DDGS I used was from one distillery in Nasik in the 90s. And then we used to get very consistent 27% protein. And now I'm sure many of you are using DDGs coming from broken rice with at least 48%, 45% protein. So we are talking of something which is highly variable. Fortunately, this is a manufactured product. So the variability can be lesser and the information available must improve. Otherwise, we will not be using it to its fullest potential. Now, a big problem, and US industry, US farming industry went through a very big bad patch on the sulfur content of DDGs. They had a lot of cows going blind and then discovering that it is coming from the high sulfur content. Again, fortunately, the variation in sulfur content of DDGS is all coming from the added sulfur. Now, whenever they are using wet milling process, before the milling, the grain is steeped. And in the steeping process, they use SO2 or SO3 to soften the grain. Another source of sulfur can be the H2SO4, sulfuric acid, used for adjusting pH just before fermentation. Both these together can add to a lot of sulfur and can cause us a problem in any species. If it is broiler, in all species you are talking of at least availability of copper if the sulfur goes up, but that is the least of our bother. It can cause polioencephalomalacia in cows just because of the H2S production in rumen and thiamine becoming unavailable in rumen. So the sulfur, unless we know what is the content, I don't think we'll be able to use this product effectively. From the US Grain Council data, US DDGS used to vary from anywhere from 0.6 to 1.8% sulfur. That is a very high variation. And unless we have control over this, we are going to limit the usage of DDGS in feed. Now, as I said, most of this is coming from the added sulfur. So when a batch of DDGS is coming, I must know what is the kind of added sulfur in that batch. And that will make job of a nutritionist much easier. Similarly, the sodium can vary from 0.1 to 0.5. Again, whoever is dealing with broiler feed formulation will know what havoc it can make if it goes from 0.2 to 0.5 without you knowing it. The sources again here, major source is the sodium hydroxide, soda used for cleaning of equipment. The traces, water used for the process can be high in sodium and can incorporate higher sodium. Now, Mr. Pari also mentioned the variation in color being a challenge. This has been a highly debated topic in US. You just Google the term color and DDGS and you will get thousands of pages dealing with the color changes. Almost everything telling you that the color does not decide the quality. But I think that is kind of wishing things away. You're wishing Maillard's reaction. Now, when you are heating carbohydrates and protein together, there will be something happening. To me, very simple physical observations tell a very complex chemical story. So, a slight color change may or may not be explained today by chemistry. We can be assured that that is reflecting some chemical changes. And the major reason for the variation is almost everybody in the industry uses the bundle tube dryers for drying DDGS. The dryer works on one end, the material will enter, the other end, dried material will come out with a variable retention time because there is not exactly FIFO happening there. So you will always see some black particles to very dark color material. And these are actual photographs from material being available only from rice, from different sources. But this is not only source. From the same source, batch to batch, you'll see color variation. There are, beyond drying, there are multiple other reasons. All of them count. But to me, organoleptic test is going to be one very important factor in selecting ingredient. And I must know what to call a standard product. Now, after a lot of discussion, the US industry came down to testing ADICP or ADIN, that is acid detergent insoluble crude protein or nitrogen. Whatever it is, and it is not a perfect indicator of the damage done, but still we must have a standard. So, whoever, and I see many people who will be involved in BIS standard when it comes to setting a standard, I think we must incorporate something to control the heat damage and to measure the extent of heat damage and should have some specifications. Now, one more variation which exists outside already, but recently added in India in last few months, some of you would have bought already partially extracted DDGS. So, some DDGs, and especially when it is coming from corn, you can have even 8-9% or more oil, and that oil can get extracted. So if the plant is supplying partially extracted or fully extracted DDGS, then what happens to the energy content? Even if I consider a very modest figure of 8,000, 8,100 kilocalories per kilo of the oil present in DDGS, and now it is removed, what am I left with? What is the metabolizable energy I should be considering for my formulation? That will be a big question. The one more bigger headache, which for feed industry, for milk industry already from 2020, it is a rule now. And antibiotic residues, the dairy companies are testing. Fortunately, in India, we don't have tradition of using any antibiotic in cattle feed. But can it come indirectly? Remember, for ethanol production, the production is being done with fermentation by use of yeast. And you are starting with a very variable material coming from field, and there can be contamination of different microbes or wild yeast, which will be unwanted for the efficiency. It has become quite common to use antibiotics to control the fermentation. Now, I'm talking of the US industry, and therefore from 2008-10, they continuously monitored the antibiotic content in DDGS and ended up having regulation. So US FDA regulates antibiotic in DDGS. As of now, currently, the only antibiotic used, allowed to be used in the fermentation is virginiamycin. In India, what is the situation? Can anyone tell me? Do we have rules? Are we going to have rules? And if we're not going to have those rules, how are we going to comply with the regulations for feed? So I think it is a good product. It is going to be available in big quantities. It will be a national waste not to use it. We have to use it judiciously, and we must keep our eyes open, know what we are entering into before we take a decision.
Grain-based distillery. So I don't have a question. I just want to add something. You said something about issue of sulfur in the distillery. So I think most of the ethanol plants which are growing right now, they do dry milling, not the wet one. I think wet milling is done only to manufacture glucose. So I believe in the near future, if the ethanol from the grain industry is increasing, then the issue of sulfur won't be that much.
True. So most of the DDGS was, which was available last 2, 3, 4 years was from rice. And there you see dry milling process. That is why I mentioned steeping as the specific process where it is added. When we see a shift of ethanol production from maize, I'm not so sure whether it will remain dry milling or not, whether there will be steeping or not. If there is steeping, by definition, there will be addition of sulfur. So only in wet milling process, before the milling, sulfur gets added. The another source, as I said, is during the pH adjustment. That is much smaller, but it remains a important source. Please remember, sulfur on one side is a nutrient. Our BIS standard mentions minimum sulfur, but on the other side, it is a poison. And we have to have limits how much we can use, and knowing how much it is coming from which ingredient is important. Any other? Yeah.
Could you please add with robust probiotic combinations? Can we, in a broiler and layer feed formulation, can we go up to 10% DDGS with the present available conditions?
Uh, you spoiled your question by saying present available. I would start with the utopia.
Okay, you can remove that part.
So I will start with the utopia, saying perfect quality of DDGs coming from non-damaged grain with not laden with mycotoxins. You can use very easily, not 10, you can go to 15 even.
Thank you.
But trouble is that is utopia. We have to be practical, and I have given the list of things which we want to consider while using. Those are all limitations. We have to deal with those limitations. Now, one of the limitation, as I said, is mycotoxins. Going to be mycotoxins, and by definition, you are concentrating the mycotoxins in DDGs. Now, whatever is present in grain, 3 times to 5 times will come to DDGs. That is our main problem, I suppose.
My question was more about the bacterial contamination because we have limited AGPs. So this alternate is robust probiotics.
So forgetting the antibiotic usage inside the fermentation of ethanol, I don't think we get too much of a probiotic activity from DDGS. It is dried. There will be dead yeast present, which is a good value addition, but not as a probiotic effect.
Sir, thank you for the presentation. It's a nice thing. I belong to the aquafeed industry. So in this forum, I want to tell that DDGS is the future ingredient. Definitely, if you say our alternative ingredient, DDGS will be the future one. It comes under number 1. But what we have seen the last 2-3 years, the quality of DDGS is not consistent, as Mr. Padi has told. So it grows from 27% to 45%, sometimes 48, 51 also. And the major challenges what we have seen by screening up so many samples pan-India, that it contains the antibiotics that you have told, that nitrofuran and other metabolites. And the major thing is the non-nitrogen substances like urea. So that is the major challenge. So how do these distillers address that? So if they can address that perfectly, so that could be the real like alternative to other feed ingredients in this scenario.
Good that you brought this out. Again, the challenges of adulteration is very much present in all ingredients, not only DDGS. Fortunately for us, I won't say the ethanol production plant will indulge in such a thing, but I have myself seen the traders going to an extent of arranging, mixing and adultering. Urea is the best thing which happened to you. So at least you could detect. Lot of people have suffered with castor meal being adulterated. And many of them have suffered very badly. Some of them I even today know that they did not know what had happened to their livestock. So adulteration is a problem. That is a problem not only for this material. This being a very highly variable material allows it. So anywhere else, for example, a very narrow band of rapeseed meal or soya, you have 46, 48% protein, and suddenly it goes to 52, you'll ask question. Here it is such a wide range that it gives more chance of adulterating with NPN, and that has to be addressed. As a thorough testing procedure, I think it is up to us to incorporate those things.
So first, let's see why BSFL, why we had to get into BSFL. The main and most important thing is it doesn't compete with any of the feedstock, livestock. Totally BSFL can be grown in waste. Waste here I'm saying, meaning is totally waste, it can't be used to any other way. Unlike Western countries where most of like even DDGS is being used for producing BSFL, in Indian scenario, we can look into a complete waste and that can be used as a substrate for BSFL. So it is not going to compete with any of the in feed which has already been used. we in India, we don't actually waste much, right? So already all this distillery waste and the industrial food industrial waste is being utilized in feed. So this could be an alternative to use into processing those food waste and industrial waste, which is completely can't be handled in any other way. Right now, only biogas production is a viability on waste that we are looking into. Primarily, we grow BSFL from vegetable waste, that is totally trash vegetable waste, food waste, even human sewage can be, even manure of animals can be used for producing BSFL. And it is a natural feed for almost all carnivorous and omnivorous animal. It is nothing new. They have been used, their biology system has already been trained to have this ingredient. It is nothing new. Maybe for formulation, this is a new ingredient. It is small and nutritious. I'll come up with the nutritious details, but it is small. If you can look into it, it itself is a pellet for some of the species without putting much effort in pelletizing. We can still use BSFL directly. That has also been done. So it is native and safe. People, we are all in feed industry, so definitely we'll know how things are in animal husbandry. We will definitely encountered BSF mainly in poultry. It is naturally present mainly in the tropical area. And safe, it doesn't carry any disease or never considered as pest, because it's there in for generations. It never evolved like houseflies or other pest. And it is environmental and sustainable because of the reasons that I have explained. So here, when we look into the nutrition of BSFL, it covers a spectrum of 18 amino acids. You can see the values are quite good in most of the cases, except for 1 or 2 amino acids. This is a sample taken from the farm, from Kobe BSF farm. And the amino acid and the fatty acid profiles, again, uric acid is one of the saturated fatty acid present in BSFL. I would say, to my knowledge, this is the only non-plant fat which has this high uric acid, mainly contributing to the immunity and general health. It also has omega-6 and 9, and compared to amino acids, fatty acids in BSFL can be engineered from the substrate that we are feeding. So increasing the level of omega-3 is also possible based on the substrate that we use for BSFL growth. What do the test results say? Aqua feed inclusion, 50% of fish meal replacement is possible based on the studies. With improved performance, here improved performance I mean to say on the reduction in the maturation period, improvement in FCRs, taste, color, and on general health in terms of immunity building. In poultry, 15 to 20% in the feed of layers, and 100% replacement as an energy source of BSFL is possible. See, all these are based on the trials that has been done, but more need to be studied. So in general, 3 to 4% inclusion for overall health as a supplement is possible, and oil supplement of 2 to 4% in nursery pigs in swine is also showed improved performance. So lot of research and trials is what we require from the BSFL industry's perspective. We definitely require a lot of trials to make this point clear, and also the research, future research, especially on processing, can help us working on the anti-nutritional factors currently existing on the limiting of 15 to 20%. So this can, to my understanding, this can be improved when we started working on the on researching on the anti-nutritional factors that exist. So apart from the nutrition, what are the different thing? What is the differentiator of BSFL? Which is making the BSFL as an ingredient standing out is the antimicrobial peptides. More than 324 antimicrobial peptides has been classified from insects, and in BSFL alone, 13 for even human application has been worked upon. Again, it's a future research oriented aspects of BSFL, definitely on improving the immunity against various pathogens like the seriously high viral infections that is affecting the livestock can be worked upon using this antimicrobial peptide. Why? Because the environment in which BSFL is cultivated, it synthesizes these AMPs, and that is getting accumulated in the biomass, which directly goes to the livestock or aqua poultry animals via the feed. So definitely a very workable option, mainly focusing on AMPs. Luric acid I have already mentioned, mainly a great energy source for early, like small chicks and nursing livestock because of easy digestibility and absorbability, highly bioavailable, improves the general health of the animal.
Consistency, availability, and cost are the three things that every feed manufacturer is looking for when it comes to ingredients, right? And that is where the problem with insects majorly starts, right? So it's a new ingredient, we have to farm insects. And why insects? Because insects consume a lot of food waste. The problem is, with variable waste, there is a variable nutrition in the insect, right? With variable nutrition in the insect, it cannot become a B2B ingredient. A B2B ingredient need consistency, right? Without consistency, something cannot become an ingredient at a large scale, right? Maybe you can send it directly to a farmer, right? So a small scale fish farmer, maybe utilizing some type of variable 10% inclusion insect in the diet works fine, right? Would a feed miller use it? No, right? And that is where consistency in the quality of the ingredient is where the industry is stuck at the right price point, right? And that is what we started solving like 3 years back when we understood the real problem statement, which is what I conveyed it to you just now, that this is what the real problem statement is: consistency at the right price point with scalable volumes, right? And that is where the feed industry would get interested. अब उसमें मेरे पास अच्छा इंग्रेडिएंट हो सकता है, खराब इंग्रेडिएंट हो सकता है, राइट? या एवरेज इंग्रेडिएंट हो सकता है. And that is where my argument is, please do not compare it with soybean. It's much more superior, right? It's much more superior in comparison to soybean, both in terms of amino acid profiles and also in terms of fatty acid profiles, if you look at it, right? Once the fats and the proteins are extracted, just like you do it with fish meal and fish oils, right? Or even in comparison to krill meals and squid meals, and I'll show you the comparisons, right? So it's much more than soybean meal. And where Sir left, right? Dr. Padi left. Supply is not a problem for them. Actually, supply is a problem for us. It's a specialty ingredient. We cannot reach 100 million tons of these ingredients. Globally, सबको भी मिला दो, 2000 loop को हमको डाल दो, we won't be able to reach that level. But what can be done is, these ingredients can be leveraged in a small quantity, right? For the functional benefits, for the chemoattractant properties, for the palatability benefits, is where we should start. We should not target 10%, 15%, 20% inclusion levels, because even if it works, it is not sustainable. We won't be able to give you those volumes. If you look at it, why insect-based ingredients? And that is where I've not shown soybean curves here, right? So I'm not much concerned about the plant-based ingredients. The DDGS is also trying to solve it, right? What we are majorly concerned, and that is in the aquaculture industry, is the limited quantities of fish meal available, right? Now, if you want to include 24% of fish meal in your shrimp diets, right, on an average, right, where is that fish meal going to come from? If, say, for example, the value has stagnated, the capture production of fish has stagnated, whereas the aquaculture production, which is farmed fisheries, is growing at a consistent rate. So that gap that you are seeing has to be bridged by some other ingredient which can fill in or replace fish meal at those 0.5 to 1% decrement levels that fish meal is experiencing year by year. So every year there is a deficit of 0.5 to 1% of fish meal which is getting created. Now that deficit has to be bridged by some other ingredient, or we find some plant-based ingredient to replace it. And that is where, if you compare between silkworm and BSF, and currently we are doing 100 tons of silkworm and 20 tons of BSF, right? So there's no down marketing advantage for me here. There's a clear advantage that you can see in comparing both the insects. This is the full fat dried insect profile, right? The crude protein 54 versus, this is our material 35. It can become 45, 30, it can become 50, 30, it can become 50, 25, right? Because BSF eats n number of stuff. Every manufacturer will give you a different profile, right? 54, 34 is what we get with silkworms. One of the things that you should note here is just add the proteins and the fats. It's 88% dry matter that we are talking about, right? So there's a very little content of ash, there's a very little content of fiber. And one thing that insects are often questioned about is the chitin that they have, right? So chitin is both good and bad. In the right quantities, it acts as a good gut microbiota promoter, right? Immunity booster, right? But with higher quantities, it reduces the digestibility, right? Now 10% or 8% in BSF versus 3% in silkworms works in favor of silkworms, right? Which gives the right quantities, but not too much. And that is where if you do the PDCAS values of silkworm pupae, it's 89%, right? Whereas for BSF, it would be anywhere between 76%. Protein digestibility assay tests, basically 89 versus 76, huge difference there. And the energy basically depends on a lot of fats, right? So if you look at it from the proximate perspective, silkworm works, and at the same time, if you look at it, it's consistent in quality because it's a monophagous species, eats only. A lot of research is still needed, right, in this industry, where we need to do different kind of trials, different inclusion levels, and do a holistic test, right? Not just look at one parameter, but we look at the quality of the meat, the quality of the egg, the other parameters as well, the overall health, maybe immunity benefits, maybe mortality dips, right? Not just the FCR values. Yes, I understand that it is the most important thing for the industry, but it has to be looked upon from a holistic point so that we can connect the dots, right? In the morning, we discuss a lot about data-driven approaches. So data-driven approaches has to be when it basically is collected in a very holistic approach.
97 में ग्राउंडनट मिल, ये अमिताभ बच्चन थे पोल्ट्री फीड के. बिना फिश मिल के, बिना ग्राउंडनट मिल के पोल्ट्री फीड नहीं बनता था. तब मैंने सोयाबीन मिल प्रमोट करना चालू किया था, और तब ये सारे क्वेश्चंस आते थे जो आज हम लोग DDGS के लिए पूछ रहे हैं या इंसेट की मिल के लिए पूछ रहे हैं. लोग कहते थे सोयाबीन मिल महंगा है, लोग कहते थे इसमें एंटी न्यूट्रिशनल फैक्टर है. अमीनो एसिड की तो तब बात बहुत कम होती थी, लेकिन अफ्लाटॉक्सिन की बात तब हमने करना शुरू की थी. यानी ग्राउंडनट में जो अफ्लाटॉक्सिन था वो लिमिटिंग फैक्टर था ग्राउंडनट के लिए. और बेसिक क्या है, आज हम लोग 40 मिलियन मेट्रिक टन एनिमल फीड बना रहे हैं, और आने वाले 5 साल में हमको 80 मिलियन मेट्रिक टन एनिमल फीड बनाना पड़ेगा. और इसके लिए हमको रॉ मटेरियल चाहिए. एग्रीकल्चर सेक्टर ग्रो हो रहा है 2 से 3%, और एनिमल फीड सेक्टर ग्रो हो रहा है 7 to 8%. रॉ मटेरियल आएगा कहाँ से? तो शॉर्ट टर्म में हमको यील्ड बढ़ाना पड़ेगा, शॉर्ट टर्म में हमको इंपोर्ट करना पड़ेगा.
Program which has been initiated by the government of India. It's a very ambitious program. It talks about us replacing 20% of motor spirits, which is petrol, with organic green fuel, which is ethanol. This is extremely ambitious, and it is led to a lot of initiatives by both the industry and the government to create capacity. Today, we are at 12% of blending. As of this month, actually, because the ethanol supply year is ending in October 31st, we will be at 12%. Last year, we were at 10%. So, you're growing at 20%. Next year, the objective is to go up to 15%, and the next year to 20%. And what's interesting about this growth is it's a natural growth dependent on our ability to produce ethanol. it's not growth led by various economic factors, etc. We just need feedstock and we need to convert it. We already have capacity. Capacity has come in leaps and bounds. Just to give you a perspective, grain ethanol used to supply 3 crore liters 3.5 years back. This year we are supplying 120 crore liters, and next year our target is 300 crore liters. And that's very important for all of you to understand, because the more ethanol we produce, the more DDGS will come out. And I'm going to spend some time in the next slide on that. Extremely important for us to understand the importance of ethanol, because it's green, it's a 360-degree program. It helps all stakeholders, starting from the government of India, starting from our economy by reducing our oil imports. The farmer is one of the biggest beneficiaries here. And let me just give you a perspective. When they first started ethanol, they used to make it from molasses, basically C heavy, moved on to B heavy, and today they are producing ethanol from sugarcane syrup. Now it sounds very simple, but it's actually brilliant, because our production of sugar is far in excess of what is required in this country. But we used to produce sugar because of our commitment to the farmers. So you have a catchment area, the farmer will come and give you the sugarcane at your gate, you have to convert. So a lot of a sugar mill industry actually used to carry stocks, and therefore payment down the cycle to the farmers was always a challenge. When we are converting from sugarcane juice to ethanol, there is no sugar production. So there's a wonderful way of balancing the sugar requirement in the country, and more importantly, the farmer gets his payment much more quicker than what they used to get in the past. So all I'm saying is, all these initiatives are excellent initiatives. It takes care of everybody in the system, provides employment, builds catchment area development, etc. I don't have to teach you about DDGS, because all of you understand that DDGS was till now being produced from rice. But from the current year, we have been mandated to use corn. Mandated to the extent that we were zero ethanol from corn 1.5 years back. This year, we are supplying close to 25 crore liters. And next year, we're going to supply 150 crore liters. So again, that leads to the fact that there will be more and more DDGS available for all of us to look at and see how best we can use it. Good news is that we are now getting DDGS from maize with aflatoxin levels less than 20 ppg in one part of the country. The bad news is we are getting aflatoxin content as high as 180 to 200 as well. Now, why is this happening? And we have very quickly discovered that it's due to the availability, the quality and farming practices in those areas. So it's aflatoxin is led by high moisture content. So when you buy the maize, your moisture content should be less than 14%. So you need to take care of that. And then necessary and very improved storage systems and processes. So we are now reaching out and working on that. Currently, we have actually done research using new technology in a lab format, of course, on reducing aflatoxin. I'm very happy to say that as of today, and I was in Bangalore last week, I think we have managed to make it almost negligible at the production source. We need to make sure that our storage protocols are good, because as I was talking to one of our esteemed members here, he said, you need to be sure that when you take care of aflatoxin, it is not when you produce, it's when you consume. So during your storage of the finished products, it has to be addressed. So we're doing all that in our protocol. And I expect that within a month's time, when we are out into doing these seminars, we'll be able to share more on this.
Padhi Sahib, you said 2.5 million metric ton would be the produce of DDGS in 2025-26. What would be the corn consumption for producing that much?
Multiply by 2.62.
So it's around.
6.5.
So don't you think there will be, because corn is also being used in poultry, dairy and aqua as a raw material?
Excellent question. I
So
think
what will happen to the price of corn when you say that you will get a stable price of DDGS, and if there is a shortage of corn, where because it's being directed for ethanol production, what will happen to the price of corn, and will you be able to maintain the stable prices of DDGS at that point of time?
okay. So let me answer that. That's an excellent question, because in the last 1 week we've had many meetings with the Ministry of Agriculture. We are working actively with IIMR Ludhiana, which is Indian Institute of Maize Research, and we are all cognizant of the fact that our requirement of around 6 million tons in 3-4 years' time has to come from somewhere. So the question you are asking me is, if your feedstock price is going to go up, the feed miller has to buy maize at a higher price, and so are we going to shift the problem from one place to another? So what we have done is we have identified 3 key areas. Today, almost 7 to 8% of our maize production is exported, which is the first, which is around 2.83 million tons, which is exported, which is one. The second is that we have a vast dichotomy in acreage and yield. It's very interesting to understand that our yields are between 2.8 to 3 tons per hectare in the largest growing area in places like UP, etc. And our yields are 6 to 7 tons in the smallest growing areas in Telangana and Andhra Pradesh. So the government is cognizant of 2 challenges, that we have to get more acreage in these states and improve the yields in the other states. So the work is on. In fact, last week we got news that they have apportioned a large amount of money to improve the quality of seeds, and also 22 distilleries have been identified who are going to look at catchment areas around their place to increase the production of corn in that area, supplementing existing crops which may not be needed as a program. So there are many programs which are being worked out. We expect that with, it's a very wrong word, I will not use that word, also with curbs on exports, you're going to get lots of grain coming back into the system, which is actually good for the feed industry, because then your prices of corn in the market will remain more stable. We also are supplementing corn with rice. We use broken rice, and we've done some work on that as well. Currently, your composition of broken rice in the PDS rice is 25%, which is which is actually very high compared to global standards of 5%. So there is some relief going to come in from there, with the feedstock of rice also increasing simultaneously. Yes, we have a feedstock challenge, and I would like to thank you for asking that question, but we are cognizant of it and we are addressing it through various forums and various actions.